We are back. So recall that last week we scratched the surface of this other topic known as an array. In English, as best you understand now, what is an array with regard to C? Anyone got something? So it's a list, right? It's some kind of variable. Let's call it noun. That's not quite right, but it's some kind of variable that doesn't store one value, but it stores multiple values. And we did see something just like this in Scratch, and Scratch called them lists. And another word that gets tossed around for these things is called vectors. But an array in C can be likened conceptually to like a bunch of mailboxes, right? An array in C is a bunch of contiguous chunks of memory. Contiguous just means back to back to back to back in RAM. And so in this case here, this might be an array of mailboxes of size 5. So I could store, for instance, one thing inside each of these mailboxes, and that's it. Now, what thing can I put in there? Well, it depends on how we declare the array. If we say this is an array of ints, I can fit 32 bits in each of these mailboxes. If I declare them the array as a char array, I can only fit how many bits in each? So just 8, right? Remember that a char is a byte, and a byte is 8 bits. So if this is an array of chars, of characters, well, I can only fit 8 bits in each, right? So that's like having smaller or bigger mailboxes. Now, if I wanted to store a word in these mailboxes, well, what's the longest word I could store in here? So maximally 5, for sure, right? If there's only 5 mailboxes. But recall from last week, it's not quite 5. In fact, the upper bound is 4, because we actually want to keep around some kind of reminder that that string, that word ends here. And so that special character, recall, was the null character, or the \0. So all 0 bits denotes the end of a string. So we can generalize this now as an array as just its placeholders, its cubbies. It's a mailbox inside of which you can put a whole bunch of values, one after the other, but by design they all have to be of the same type. So let's actually see this in action. Let me go back to my gedit window here. Let me open a new file. And I'm going to go ahead and create something that just lets me play with a string. Let me go ahead and first declare this as, let's say, in John Harvard's directory, as string1.c, because it turns out, even though we just introduced this jargon last week of an array, we've been using arrays actually since week 1 when we first introduced a string. Because what's a string? Well, it's a word, a phrase, sentence, paragraph, whatever. But what is that? It's one character after another, after another, after another. So this thing we've been calling string casually is actually an array of characters. So we can now peel back that layer. So let's go ahead and include, let's say, the CS50 library. Let's go ahead and include standard io.h. Let's go ahead and do int main void. I don't want any command line arguments just yet. And then in here, let me go ahead and ask user for string. So I'm going to do string s gets get string. And then what do I want to do with this? Well, first let me figure out the length. Int, let's say n, gets strlang of s. So it turns out that there is a function called string length, or strlang, and it happens to be declared in a file I actually don't remember. So what are my solutions here? So let me actually go and open a terminal window. And I can actually type, if I know the function's called strlang, I can say man for manual, strlang, enter. And you'll see a few things, among which at the very top is a reminder as to what header file it's in. So I apparently need that. And now this is a little cryptic at first glance, but this will make sense before long. The function is indeed called strlang. It takes one argument, but that argument is apparently not a string. What's data type is it apparently? Const char asterisk for some reason. Well, as a teaser, a star here means pointer. A pointer is a memory address, and we'll actually come back to that. But for now, just assume for simplicity that everything highlighted here in white is just a string, quote unquote. The keyword const char star is what we have simplified temporarily in the CS50 library as quote unquote string. Now as for this here, size underscore t, this too is a teaser. It turns out that in C you can declare your own data types. If you don't want to confine yourself to just int or float or double, you can actually create a student data structure. You can create a human data structure inside of which are multiple fields, like a student's name, an ID number, and phone number, and the like. But we'll get there too. But for now, just know that size t happens to be synonymous with int. So realize that when looking at man pages, sometimes they actually won't make much sense at first glance. And in fact, not till mid to late in the semester will you look at this and be like, I remember what that is. For now, just kind of reason through as best you can that, OK, this at least means I need need this header file. So let me go ahead and go up here and include string.h, and then recall this reference in particular. On CS50's website, we have, under resources, the following link at the very top. So to C reference, this is a relatively more user-friendly reference guide to all of C's functions. And even though many of them might seem new, in total, there's not a huge number, certainly not as many as Java for those with backgrounds. But let's go to C string and character, because it feels like I'm doing something with strings. And sure enough, if I scroll down, strlen, there it is, returns the length of a string. Let me click that. And now, this isn't all that enlightening in this case, but you'll find that a lot of this documentation includes examples, includes links to related functions. So hopefully, it'll at least answer some questions. But honestly, when in doubt, just try it. So let's see what happens if I pass strlen an argument that's of type string, aka const char star, and store its value in an int. I'm not going to bother with this size t and all this. I'm just going to go with what feels simple to me. So now I have in n the length of the string. Let me go ahead and have a loop. So for int I gets 0. Let me do I is less than n. Let me do I++. Then let me open some curly braces. And what do I want to do? Well, let me go ahead and treat this string as though it is an array of characters. So let me go ahead and printf a single character, so %c, one at a time, and then I'm going to put a new line. So in short, I want to print one character per line out of whatever's in S. But S, I kind of need to use I here somehow. How do I get the ith character of S? Yeah, so the new syntax we introduced was this, S, open bracket, I, close bracket, and that says go to the variable S, then index into it, so to speak, to the ith location, 0, 1, 2, 3, and print out that particular letter. So let's see what happens now. So this feels like it should iterate from I to n, where n is the string length, and then print out whatever character is at that location. Any syntax errors before I try to compile? All right, let's try. So let me just go down here. This is make string 1, enter. OK, good sign so far. Let me go ahead and do string 1, enter. And now let me type in hello world, enter. OK, it feels like that actually did work. If I scroll back up, we see HELLO, one per line. We see the spacebar character. And then voila, we're at the very end. So what's the takeaway here? Well, apparently all this time, we've actually been using arrays. We just didn't slap that label on it. But in a string is just an array of characters. But here's where you need to be a little careful. Suppose I kind of messed up here. And suppose I did this. All right, so you already know, hopefully, instinctively, this is bad. And unclear what's going to happen, but going beyond the length of something feels like it's at least going to make some aesthetic bugs. So let's see what happens. I'm now iterating from 0 up through n, which means if the length of the string is n, this really means a total of n plus 1 iterations. Because if you start at 0, you get one extra one, which is probably one too many. So let's recompile. So I'm going to rerun make string 1, enter. Let me rerun string 1, enter. Hello world, enter. Huh. It doesn't feel so bad. So that doesn't seem to be too problematic. Why did I get a space? Well, that's how 0, in this case, is being interpreted. So \0 is being automatically inserted into S for me. So we'll see this before long. But for now, know that what getString does is it actually reads one character at a time, another from the keyboard. And then when you are done hitting that last key on the keyboard and you hit enter, when you are the user, it then adds in a \0 to the very end of the string. But when you call string length, it does not, in fact, count that \0. So in other words, if I type in hello, HELLO, string length is going to return what value? 5. It's not going to return 6, even though how many bytes are being used? Well, 6, because there actually is that 6th 0 character terminating it. But we'll see this before long. Now let's just do something crazy. I would like to go 100 times the length of this string just to see what's in memory, right? If I argued before that inside of RAM are these leftovers from previous function calls, let's see what's in there. Let's print them out one character at a time. So just to keep things a little more readable, let me not do the new lines because I'd like to just see it on one screen rather than scrolling. So let's get rid of the new line. And now let me go ahead and scroll down. Let me rerun string, make string 1. String 1, enter. Let's type in hello, enter. Ooh, that's funky. What is that? Right, so it turns out there's a lot of unprintable characters in ASCII, right? If you think back to ASCIItable.com or the chart we had a while ago, if you go to ASCIItable.com, I think Tommy mentioned this in the walkthrough last night. This is frankly an unnecessarily complex looking chart, but this just maps letters to numbers. If we scroll down to 65 over here in the top right, it maps to A. But notice that over here, there's crazy things like form feed and shift out, shift in. I don't even know what some of these characters are. Well, neither does the terminal window. And so it prints them as these funky garbage characters. Frankly, let's really mess around here. 1,000 times the length. Let's see what we can see. All right, go down here, zoom in, remake. And again, remember this keyboard shortcut. If you're tired of typing the same thing again and again, you can always hit up and down to scroll through your history. Or you can type exclamation point and then start matching whatever the last command was you typed that started with M and hit enter. And your blinking prompt will figure out what it was. So I'm going to now go ahead and rerun string 1, type in hello, enter. Still not doing much. What might it be doing, though? Can I go further? It's getting a little crazy. Make. Rerun, hello. Aha. So some of you have seen this already, yes? If so, good job. Very advanced already. So this is bad, right? A segmentation fault just sounds bad. And we did induce this last week when I did what? Remember when I kept calling, I forget what the function was called. Maybe it was foo or something silly. Remember I just kept having foo, call foo, which called foo, which called foo. And what did that mean? It meant that more and more RAM was getting allocated until finally it crossed over its segment. So you get a fault. And core dump actually is silly terminology, which means you now literally have a file in your current folder called core. And what do you think is inside of that file? It's actually useful. It's a bad sign. It means you screwed up or I screwed up. But what's inside of it? It's kind of some forensic information. Inside of that core file is essentially the entire contents of the appliance's RAM at the moment your program crashed. Now, it's not everything, because that would be huge. It's only as much as you need to see. But we'll see in future weeks a tool, again, called the debugger, whereby we can do a little forensic analysis of this file and figure out retroactively where and hopefully why my program failed. Now, what happened here? Well, I iterated like, 100,000 times farther than I was supposed to on this string. So what does that mean? Well, it doesn't mean that I kept calling functions again and again. It means I simply tried to touch or print memory that was way out of my boundaries. And so this is a bad thing. So hopefully that issue makes a little more sense. But turns out we should be a little more careful still. I can make this program crash in other ways, because it turns out that getString doesn't always return a string. It's hard to simulate this, but there are ways where a bad guy, or even we, if we were really crafty here, could tell getString to return without even giving any characters whatsoever. And so if we actually read the documentation for the CS50 library, which we can do so as follows. I'm going to go open up gedit, and in today's source code, in the source directory, is a file called cs50.h. So this has been in the appliance all this time. You've not had to care about or see it in person, but you'll see at the top some fancy stuff and some files we haven't seen. But let me scroll down and point out just a couple of details. So this, again, is cs50.h. Every time for the past 2 weeks, you've been saying include cs50.h. What has GCC been doing for you? It's been opening this file and effectively copying and pasting its contents at the very top of your program and then proceeding with your own code. What is the point of that? Well, it means that no matter where you call getInt or getString, the compiler already knows about it, because if we scroll down further in this file, notice that we put all the function prototypes for all the CS50 functions in here with a whole bunch of comments explaining how they work for you, the human, so that no matter where you call getInt, getString, getLong, the function prototypes have already been declared for you, because again, when you do sharp sign include, it's like copying and pasting this file at the top. Now, what about string? How have we been simplifying that all this time? Well, again, you can declare, you can define your own types in C. And again, we'll come back to this, but that one line is what makes possible the data type we have been calling string all of this time. But let me scroll down as